All right. We're going to talk about, so we talked about functions and relations. We talked about what those graphs look like. What's an example of a function? What does a function look like? If I were to ask you, what does a linear function look like? What type of a drawing would you draw me? Actually, draw it right now. In your desks or somewhere, draw me what a linear function would look like. Just very briefly. Doesn't have to be exact or precise. Just give me an example of what you think a linear function would look like. Wonderful. Put arrow with it.
He went to get his burgers and he didn't come back with it.
I have none left. I have none left. You might have to go bug Miss Helm and see if you can get you some markers. Okay, so for the most part, I see a lot of lines that look like this. What's one thing I could add to this function? I'd probably put arrows on there. What do those arrows represent again? It's a continuous function. It goes on forever. That pattern goes on forever. Okay? The reason why this is a function, again, for every value of x, Logan, there's a value for y. Okay? The other thing that we're talking about is we talked about linear functions that are either increase or decrease. When we talked about describing the graph in words, we've talked about that, right? How we said, is the graph going up? Is it going down? Is it going sideways? What have you, okay? How you know whether a function is going increasing or decreasing, it could look like this, is what's called its slope, okay? Or the rate of change, or the rise over run. We're going to talk about all of those today, okay? We're not going to relate it to an equation just yet, but I'm going to introduce the idea of why we even have slope and why we have that rise over run, okay? We're going to go through a handful of different examples, and hopefully you'll have a good indication as to what's going on. This calibration is just awesome. All right, we've done our independent variables. What is an independent variable? Do you remember? What is an independent variable? When you're doing a graph, an XY graph, an independent variable is just x. What does an independent variable mean? Yes, it's on the x-axis, it's horizontal. What does it represent? Typically, what's an example of an independent variable? Anybody guess? Points on the grid, yeah. Give me like if I were to graph if I were to graph a scenario. Let's say I'm driving to Edmonton. Driving to Edmonton. I almost said it again. Driving to Edmonton. And I'm doing the gas over time. What is my independent variable in that scenario? Time. Does time change? Time changes, but is it depending on something else? Is it expected? Right? After 5 minutes, what comes after? What comes next? 6 minutes. What comes after 6? 7. It's predictable. It's expected. Okay? However, in the scenario that we're talking about driving to oh my goodness, why do you keep saying that? Edmonton. What changes? If I'm driving to Edmonton and I'm measuring my gas, someone from Ontario is calling me right now. What's changing? My time isn't changing, but what is? The gas. Okay? Okay? My dependent variable would be the gas that I use. Obviously, when I get to Edmonton, am I going to have, guys, girls, when I get to Edmonton, am I going to have more or less gas than what I started with? Okay? And how do I know? Because I've gone over an extended period of time. So gas is dependent on the time. Time is an independent variable. That's what they're talking about here. Okay? If we use this example that they're talking about, and I think they're talking about the rental of a vehicle, when we look at our table of values and we have this representation, okay? They're doing, I guess the scenario is cost for a car rental is $60 plus $20 for every 100 kilometers driven. The independent variable is the distance driven and the dependent variable is the cost. Makes sense? Because not only do we have time as an independent variable, distance can be an independent variable, height is another example. Okay? cost can be dependent because it depends on something else. Okay, Logan? Here, you see that my x values, and typically when we've done our xy values, or our xy table of values, we keep our x variables consistent with how we increase them, right? If I said that we had an xy chart, what are my 5 go-to points that I use? -2, -1, 0, 1, 2. What am I increasing by each time? 1. Do I change? Do I fluctuate? Or is it always constant? Constant. Okay? This stays the same. My increase here, +1. Increase here, +1. Okay? Notice the same thing's happening for the x variable for this scenario. They're going up in increments of what? 100. Okay. How we know we have a linear function, do we remember we talked about that last day when we had, well, I guess we didn't really talk. We talked about looking at the y value and determining if it was a function or a relation, correct? How we know based on a table of values whether or not we're dealing with a linear function is if our y value does the same. Okay? If it constantly is increasing at an exact rate. In this scenario, the cost starts at 60, and for every 100 kilometers, how much do they increase their price by? 20 bucks. 20 bucks, 20 bucks, 20 bucks. As soon as you have a constant increase, you know that you're going to be dealing with a linear function, okay, or a linear relation. Now we can measure the slope, or what's called the rate of change. Okay? If we keep going here, they talk about the same set of ordered pairs. Similar idea. We've seen ordered pairs. Everything is increasing by 100. For the x value, the y value is increasing by 20. Same thing for a graph. We know now, based on those two scenarios, those two representations of data, we have a graph that gives us a linear function. Would you say that's linear based on that graph? Would you say it's linear based on the table values? And on the ordered pairs? Do we get that? Does that make sense? Okay? If it's a constant increase over time, it has to be a linear function. Okay? We can also use what's called, well, this is kind of the formula-ish about rise over run, because now we can find the rate of change. We know that after every 100 kilometers, how much do I charge? $20. And we can actually find out how much it costs me per kilometer. Okay? How we do that in this scenario is you're taking the change in the dependent variable over the change in the independent variable. They took $20 divided by 100, 20 cents per kilometer. You are charging, if you're renting a vehicle, you're getting charged 20 cents per kilometer you drive. Okay? Proud of you. That's awesome. Okay, let's keep going. We also have a formula for that. So now we've determined that our rate of change is 20 cents per kilometer. We're going to start, I'm going to introduce you and just basically show you that our linear formula that's going to become your best friend for the rest of the semester, basically. I don't know, that's a little weird to say it's your best friend, but you're going to be using it quite often. Y equals mx plus b. That's the general formula for a linear function. All of our linear equations, when we talk and you actually have to make a graph or make an equation, this is the premise. Y equals mx plus b. Anybody remember, I don't know if I've talked this before, have we said what the m and the b represent? No? Okay, that's fine. M is our slope. This represents our slope or our rate of change. Okay? They use slope, rate of change, kind of intermittent. They use them kind of back and forth. Okay? We also have this x value. We know the x value is usually represented as the independent or the dependent variable. X usually represents which one? Independent. So this becomes our independent. This calibration gets worse as the minute goes on. So I apologize if my font usually, my writing is pretty bad to begin with, but it's going to get worse. Okay, y typically is what? Independent or dependent? Okay, so the only value we have left is this little b. Okay, I like to call it the initial cost, or it's actually in math terms, your y derivative, okay, or your y-intercept, what you start with. Okay, so for now, let's call it non-math. Let's call it the initial value. Do you see why we have 60 in that formula? So our original formula that they've written down was our rate of change, which you said was 20 cents per kilometer. Okay, why do we have 60?
Because that's the cost you started with.
In order for me to rent the vehicle, it cost me $60 to start. Okay, make sense? Awesome. Now, let's look at this scenario where we've got two different types of table values. I want you to write down either on your desk or in your notes, table 1 or table 2, which one is linear and which one is not, and tell me how you know, and prove it basically, okay? So in your desk or with your group, I want you to talk about which term or which table of values is the linear function, and how do you know? Okay, go ahead. You can either write it on your desk or you can talk with your group, okay? I don't think it might be, because there is a formula.
Yeah, but if it's that simple,
It's not just, it's actually weird because it comes into as a function. You're not just adding, no. Yeah, you're not just adding 9. A way to prove it is determining what the change is per point. Okay? So you get a voicemail? I know. Maybe. They're probably trying to sell me something.
Just like,
Which one is linear? Which one is linear, guys? First or second? How do you know? Each x or y, each y value is increasing by what? I really have to focus on how I'm writing it, because calibration's off. Okay, the other thing to keep in mind, okay, don't just assume that because the y value is increasing by the same amount, your x value also has to be increasing by the same amount. Does it have to be increasing by 1? No. What's increasing in this scenario? It's up by 5. Is it constant the whole way? Okay. It is not. That looks awful. It's not a make or break, but just be aware that just because this shows up as a constant doesn't mean that it's a linear function. And to prove that, I could have something that looks like this. Yes, this goes up by 5, but this could be 1, this could be 8, this could be 50, this could be 100. Yeah, this is going up by 5, but this goes from 7 to 42 to 50. Okay, is this a linear function? No. Okay, so it's not a make or break, but just be aware of it. How do I know? Oh my goodness. How do I know this one's not a function, or a linear function? First one I go up by 75, the next one I go up by 325, the next one I go 375, and so on. Okay? Pretty simple. If it's not a constant term, it can't be linear. Right? Same thing. Go. Which one is linear, which one is not? Sorry. I was dancing. My bad. Which term is linear, which one is not? Justify. If it is linear, tell me what the increase is. Alright? Not yet. Talk with your group. Unless you have to go to the bathroom.
D.
That with your little powwow. Which ones?
Awesome.
A or B, first or second, which one's linear? B is. How do you know? X is increasing by what? And Y is increasing by, Zach? Jacko, I know this one. No Family Guy reference again? Sorry. Okay, how do I know this one's not? It starts at, you're increasing by, well, it's actually decreasing, right? This one decreased by 3,600. This one decreased by like something 60. Okay, if I were to actually graph this function, it would start, it would look something like this. Okay? Okay? We didn't do that in the last example. What would, having said that, this one would look linear, right? This one would have an increase of this. What would this graph look like? What's happening in this graph? Is it increasing rapidly or is it decreasing? It would be, it starts slow and then it's going to eventually increase more rapidly. Okay? It almost looks like if I were to cut a U in half. Okay? This graph actually is very similar. You could probably measure this using a parabola. Remember the polynomials we were dealing with? Okay? You could justify, you could make the case that this could be some kind of a parabola. Okay? That might be something that you would be into. Okay. Next question. Water tank in a farm near Swift Current, Saskatchewan holds 6,000 liters. Graph A represents a tank being filled at a constant rate. Graph B represents a tank being emptied at a constant rate. Which is the independent and dependent variables? I think we can do that as a class. What's your independent variable for this scenario? Time. What's your dependent variable? Volume. Does everybody get that? Does anybody not get why time is independent? Enlighten me. Why is time independent?
Because it's predictable, you can't change it.
You can't change it. It doesn't depend on anything. Time is time. Which is time? Whereas the volume is going to depend on what time or how long you've been emptying or filling up a tank. Good? Determine the rate of change. Okay, let's talk about how we're going to find that rate of change. Actually, you guys talk about it. Let's have you guys think and girls think about what is my rate of change going for the tank graph A and graph B. I want you guys and girls to try looking at that graph, telling me what the rate of change is. So how do you know it's increasing? How do you know it's decreasing? That means Jerry, you get off your phone. So
Why does it take this guy 2 hours to fill up his gas tank?
It's a water tank, and it holds 6,000 liters.
6,000 liters or 6,000 cubes?
Cubic, it should be 6,000 cubic feet. Well, maybe not. It might be just liters. Yeah, let's make that vehicle over 20,000. Rate of change, guys. Tell me what is the increasing rate? What is the decreasing rate? 30 for what?
What he's doing is not.
Okay, what's the second one? The second one's still 30? We're adding up and come look.
You know what? That would just make me nice.
You guys figure it out? What are your rates of change?
She knows that.
You guys are talking about this. So you guys got your rate of change? All good?
First one is just 20 minutes.
Instead of having a pump to fill it,
What is it?
it just drinks itself out.
Yeah, the reverse was the dividing thing is to get like 20 cents.
For what?
So you pull the plug out of your bathtub.
That's 2,000.
Because when you're filling it, you require energy.
It is
it's empty and it's just
Yours
closed
is
in a
about
direction.
2,000 maybe.
Those are constant.
That's constant. How do I know this is constant? What graph, what shape is it?
Second one, the first one. Second one. Oh, well,
The
okay.
dots are just indicators, so that they have a point here, they have a point here, and they have a point here. Just because the points are staggered, doesn't mean that the range is shifting. Does that make sense?
No, the answer for the first one is 8.0.
These are different points. Could this be a point?
Oh, but we're starting at
Point here,
5,000.
Let's say this is here, say this is here, say this is here. I can find this out. It just might be like the first teacher testing it. Check it out. Check it out. Okay, let's bring it back here, guys and girls, in 10 seconds. Okay. Who wants to share how they found the first rate of change for graph A? How did you find the rate of change for graph A, Jared? Exactly. Get off your phone and then you might be able to answer. Okay? Who wants to share a strategy? Okay, I want to see what you guys and girls came up with, and I'll show you kind of some different ways to solve it. Go ahead, Logan.
I saw that it was 2,000 for every 40
Huh?
consistently, and then I just reduced the fraction.
Awesome. So Logan found that the rate was going up 2,000 liters. It took him 40 minutes to get to 2,000 liters. Could anyone figure out how to reduce that as quick as possible, or how could you reduce that fraction?
You divide by 20.
Okay. Say it again. 505. Okay. How I would have done that? I can cancel the zeros right away, right? I can take out 10. What does that equal? 200 over 4. 204 is divisible by what number? 2. Cut it in half. 100 over 2. Cut it in half again. 50 over 1. What's my rate? 50 liters per minute. Is that the only way to solve it? Absolutely not. Okay? That's one pretty valid way that you can just look and visually say, hey, it took 2,000 liters to get to 40 minutes. Okay? One way that we'll talk about is using the rise over run. Okay? And that's kind of what you had done here. It took to get to 2,000 liters, it took 40 minutes. Another way that we're going to show is actually using the slope formula. Okay? The slope formula, if I can scroll down, formula for slope, if you're ever just asked a scenario where you say, hey, tell me the slope given this scenario, the formula, y2 minus y1 over x2 minus x1. Has anyone seen that formula before? Jaden, have you seen that formula before? Okay, if it is brand new, I don't want to have people goofing with markers or not listening, okay? What should be the first question you're asking when you see this formula?
What does it mean?
What can I do? How do I figure those out? What the heck does y2 mean? Or y1? Does anybody have any ideas what those 2's and 1's mean? Could. If it was 2y. Okay. Do we remember what ordered pairs look like? What's an example of an ordered pair? 1 and 2. What does 1 and 2 represent? 1 is the x, 2 is the y. Could you classify this being point 1? Let's just say this is our first point, right? This being the x value, this being the y value. Give me another point. Any ordered pair? 2 numbers.
2, 4.
2 and 4. Fantastic. Okay, let's call that point 2. 2 being x, 4 being y. So if I wanted to use this information, I could say that x1, x2, y1, and y2 are as follows. If I told you x1 is 1, what do you think x2 is going to be? 2. I told you y1 is 2, y2 is 4. That's where the, sorry? That would be, and then I would be able to use that information to find my slope. So how I would input this would be, I would simply rewrite my equation, or my formula, and instead of writing y2, what number am I going to write now? 4. And instead of writing minus y1, I'm going to write 2. y1, which is 2. x2, I'm going to write what? 2. And x1, I'm going to have 1. What's 4 minus 2? What's 2 minus 1? My slope in this random scenario is 2. Can I prove that? How I prove that with this scenario? In this graphic, when I print the notes off or I post the notes, you'll see that there's dots here. Okay, these dots represent specific points. You can choose whether you want to have one as 0.1 or 0.2. The only kind of suggestion is that in North America, how do we read anything? We read from left to right. So we should be picking 0.1, the furthest left. 0.2 should be the next point to the right. So 1 point could be the 2,000, or the, I guess, what point would this be? If anybody can see it. 1,000 and half of 40, 20. That's 0.1. Pick another point. Anybody can see.
50 and
60 and 3,000. Okay, so 3,000. Oh, I'm writing them wrong. You're right. My bad. First one was 20 and 1,000. What was this one? The second one you said it was 60 and 3,000. Okay, if I'm using that information, y2 minus y1 divided by x2 minus x1, what do I replace? What does y2 become? You need these, I'll bring it back up. What's y2? 3,000. What's y1? 1,000. What was x2? 60. And what was? What's 3,000 minus 100? Or 1,000, sorry. 2,000. What is 60 minus 20? 40. Did we start with that? It reduced to what? 50 over 1. 50 liters per minute. Yep. Yes, I can. What's your question, Miss Madison? No, you can pick any of those ones. Yes. If you can, that's a good point, guys and girls, listen up. If you have a point on your graph that you know for certain, like for example, I know that 2040, that's got to be at a point. Okay? Just because it's not indicated doesn't mean I don't have to use it, or that I can't use it. Okay? If I can identify and say, yes, that's 2040, use it. Okay? Make sense? No, it's not. I can literally use any and all of those points, as the only method I have to make sure of is that point 1 is on the left, point 2 is on the right. Okay? Having said that, what's my rate of change using either this formula, y2 over y minus y1, x2 over minus x1, to tell me what the rate of change is here? Go ahead. I want you to prove it to me somewhere. What one? you try?
Okay.
You're doing the second one. So you're just telling me what the rate of change is using. You don't have to use the slope formula. If you know the rate of change another way, use it.
Is it an increase or a decrease?
How do you know?
The other way around.
How do you know?
It's like you've got this little section, so like, so it's like, hey,
It's a good drawing, guys. It has a lot to do with math. Can you erase that, please?
It's like, you walk in, she's like, actually, it's like really what you want to be here in a week. Well, I need it now.
It just becomes. Now the question is it increasing or decreasing? So what should happen to your rate? It should be negative. Good. What'd you have? Perfect. All right. Now, how many people use the formula y2 minus y1 over x2 minus x1 to find this equation, or this rate of change? Okay? You did not have to use this one. You could use another rise over run, and I'm going to show you what that looks like here shortly. But if you did use y2 minus y1, you needed 2 points. What would be 1 point that you could use that you see on the graph? What's an easy point that you can see? 60 and 1,000? I see 60 and 0. Right? I could use that though. 60 and 0. I'm going to put that as my 0.2 though. Why am I putting this as 0.2? It's the furthest to the right. What would I use as 0.1? Huh? Whose underpants do you see? Oh. Which point do you see? 0 and 6,000. Awesome. So I'm at 0 time and 6,000. You guys and girls have just discovered the easiest way to use slope. Okay? Easiest way to find your points, if you're given a scenario that has one at the y value and one at the x value, use those points. Because if it's linear, they have to connect at a constant rate. Correct? You have zeros. I like dealing with zeros as much as I can because it makes math so much easier. Right? So what does my y2 minus y1 formula look like? I'm going to erase this. Yeah, I'm going to erase it. Just to give me some room. y2, what does y2 become? What number? 0. y1? 6,000. x2? 60 minus 0. Do you see why the zeros are a little bit easier to deal with? What's 0 minus 6,000? Negative 6,000. What's 60 minus 0? Just 60. The 0 is reduced. 600 over 6, I can divide both by 6. Negative 100 over 1. What does that negative represent? It's decreasing, okay? If you have a negative slope, that means that your rate is going up or down? Down. If it's positive, it tells you it's going up. Okay, we're going to talk, I think the next slide actually tells you the difference between an increasing, a decreasing, or a negative slope and a positive slope, no slope, and an undefined slope. Okay? This is not the only way to solve this, though. If I wanted to use what's called rise over run, I could use that as well. Rise over run literally looks at, when I think of rising, or falling, I guess we could still go rising. Am I talking north-south or east-west? Rising is north, so we'll be going from south to north. If I want to go from point 1, this point here, to this point here, how far down do I have to go? So my rise is positive 2,000 or negative 2,000? Negative 2,000. So if I'm using rise over run, I'm going down negative 2,000. Okay, so I've gone down to 4,000. How far over my run has to deal with east-west, correct? Okay? How far over am I going to get to this point? 20. So I'm going down 2,000. I'm going over 20. Now, because I'm going to the right, does that make it positive or negative? Makes it positive. 20. Does my formula still work? 200 over 2, which equals 100. Negative 100, sorry. Was it the same answer as I got before? Absolutely. Rise over run. Y2 minus Y1, X2 over X2 minus X1. Sorry? This one here? Same thing. So if I'm starting, this is that. I'm going to erase this. Pick a point. Pick a start point. Easy point. Starting your starting point. If I want to go from 0, and I want to go to 2,000, how far up do I have to go? 2,000. How far to the right do I have to go to get to my line? Who? 40. What's 2,000 divided by 40? Didn't we get that earlier? It gave us 50, right? Guys, girls, that makes sense? Not bad? What I want to stress here is that slope is something that you've got literally 2 and 3 and 4 different ways to solve it. Okay? It can be solved using an equation. If I give you an equation, you can say, thank you, Mr. Dillon, you just gave me a slope because it has to be in our equation. If I give you a graph, you've got 2 options, at least, to find it. Okay? Whether it's using the slope formula, or if it's using the rise over run formula, or strategy. Okay? Are there any questions on that? Keegan's good? Awesome. Okay, we're going to go and introduce some of the, well, we just talked about rise over run, so I don't need to talk about that one. Here's where we're going to talk about what these types of slopes look like. We just kind of talked about what an increasing slope looks like. Okay? If I have an increasing slope, is my slope positive or is it negative? Positive. So what does my graph do, guys and girls, from left to right? It goes up. If I were to have a line, and I started here, it's going to go up. And it's going to keep going both ways. Okay? We're now getting into that rhythm where we're going to consistently start putting continuous graphs on. Okay? Having said that, a negative slope, what's that going to look like? From left to right, it's going to go up or down? Go down. It's going to go around. And then, I like that, thank you. Okay? Negative slope means going down. Now, what I want you to do now is I want you on your table or with your group, tell me what a zero slope looks like. Positive, negative looks the same, is pretty easy. Tell me what zero slope looks like. Remember, it's got to be linear, so it can't be away. What's wrong, David? It's linear. Okay, it's still staying linear. Yeah, it would depend on the y value. Exactly what's it doing. Okay, what's the prognosis? What are people kind of determining? It is horizontal. I want to keep my lines. Someday I'll be tall. Probably not. Maybe if I keep eating my vegetables. Okay? A zero slope represents a horizontal line. Okay? You cannot have a slope if your line is horizontal. It is not increasing, nor is it decreasing. Having said that, what do you think an undefined or no slope looks like? What does a graph of a line that has no slope looks like? Kind of process of elimination, right? This one is increasing, this one is decreasing, this one is horizontal, this one has to be vertical. Which makes sense because as we increase, we're getting our slope is increasing, going faster and faster and faster to the point where it's just completely directly straight up. Okay? There's no increase. It's going to go stay at that x value forever. That makes sense? Especially with those arrows. That arrow represents that it keeps going at that pace for the end of time. Okay? Straightforward? Let's keep moving. Okay? I want you guys, I'll show you how. Now we can actually figure out the slope based on different graphing. So you may get a scenario where I give you a chart or a graph paper and I say, here's 2 points, tell me how to find the slope. What would be, without even doing any math, what would be the strategy? Could you use both strategies? Rise over run and the formula? How many people say yes, how many people say no? Thumbs up? Alright, cool. How do I find 1 and 9? Thank you. How do I do that? Where do I put the 1? Where does the 1 go? X value of an ordered pair always goes left to right, so I go 1 to the right, and what do I do with that 9? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? That's point A. This is 1 and 9. Okay? What about B? 4 to the right, 1, 2, 3, 4, 1, 2. Okay, if I'm trying to find the slope, that's like saying I'm trying to connect these 2 dots together, right? Which formula do you want to? Which one do you want to use first? Rise over run or the formula? Formula. What becomes y2? Which one is y2? How many people say 9? How many people say 2? Why is it 2? Christian, why is it 2? Yeah. Why is this value, why am I picking y2 as 2? Furthest to the right and passing. 2 minus, what is y1? Process of elimination, it's 9. Okay? Well, x2 is 4. Y1 or x1 is 1. What's 2 minus 9? Negative 7. 4 minus 1 is 3. Can I reduce that any further? No. Is it okay to leave it as a fraction? Why? Do I like fractions or do I like decimals? Fractions are way better. Okay, fractions is more accurate, and it's actually a lot easier to figure out my rise over run. Keep it as a fraction. Does it make sense that the slope is negative? Why? Why should it be negative, Heather?
Because the 2 minus 9 would make it negative. Because
okay, I like that. What's my graph? Well, what's my graph doing?
going down.
Therefore, it has to be negative. In order for me to represent that my graph is going down, my slope has to be negative. Awesome. If I want to do the rise over run, I'm starting at this point. If I wanted to do the rise, am I going up or am I going down? Ooh, I'm starting at this point. I'm going down. How far do I have to go down? 4, 5, 6, 7. So I'm down negative 7. And how far over do I have to go to get to the next point? 1, 2, 3. Negative 7, positive 3. Where do I see negative 7, positive 3? This is another reason why I like to keep it in factored form. Because, the factored form, as a fraction, Jaden, because I already have those terms. Whether I use my formula or if I use my rise over run, it's still going to give me that fraction. That make sense? That makes sense? Yeah? Yeah, I would keep it as a fraction every single time. If you're using rise over run as your formula and you're given a graph, it should always be a fraction. Now sometimes you might get the fraction that you have to reduce. Like I might have picked maybe maybe this kept going and I picked the next line down. Okay? It just has to be reduced to simplest form, and the simplest form will always give you, in this case, negative 7 over 3. The only way it could not be a fraction if it was a whole number. So if it was 100 over 1, you could just say it's 100, right? Or remember it was 50 over 1? But still, that still tells us that the rise was 50, the run was 1. Make sense? It's always going to be a fraction. Keep it as a fraction because that makes it easier to find. Having said that, guys, girls, I want you to tell me what the slope is of this line using your choice of a strategy. Go. Not everybody will. You guys are doing phenomenal, by the way, and girls. Girls are doing phenomenal. Yep.
Your 0 is another percent of your life.
I apologize. Yeah.
Whatever.
Okay, Eric, let's find the slope. Yes, Lord. How do I find the x and y? Doesn't matter. Huh? Sure. Does 1 and 2 work? No. I know. Yeah. Oh. This has to be 0.
You don't make it a fraction.
Kind of nice done.
This is why we didn't leave the paper.
That help? I think that, you know what, actually, it's just missing. It's just trying to keep one. Hopefully that helps. Okay, guys, girls. Clearly, you've got some. Eric. Okay. One of the questions I had people walking around, most people got it. One of the questions that was brought up is, how do I pick points? Can I pick any points? I can pick any 2 points as long as they're on the line. Okay? It's fine, I'll wait. It's fine, I'll wait. Thank you. I can pick any 2 points. Now, the difference between picking this point and picking this point would be what? Why would I pick this point as opposed to this point? Can I get an accurate ordered pair here? I don't know for sure if this is 3.5 or 3.4 or 3.6 or 3.45, but I know for a fact that this point here is at 2 and 3. That makes sense? This is absolutely going to be 2 and 3, whereas I don't really know if that's 2.5 or not. Okay? Pick your points as best as you want, but make certain that they are points that are for sure on your graph. An example, the easier ones, usually the y-intercept, or where it crosses the y-axis, and where it crosses the x-axis. Those are your easiest for sure ones, as long as they are whole numbers. What is my ordered pair at my y-axis? 0 and 4. What is my point at the x-axis? 8 and 0. If I use my rise over run, am I going up or am I going down? So right away, should I be putting a positive or a negative? Negative. I'm going down how far? 4. How far over am I going? 8. What is 4 and 8 as a reduced fraction? Negative 2 and 4, which also reduces to negative 1 over 2. Okay. If I wanted to do my formula for slope, which of these terms would be my y2?
0.
What would be y1?
4.
What is x2?
8.
What is x1? What's negative 0 minus 4 is negative 4. 8 minus 0 is 8. This becomes 1 over 2. How's we doing with that? Awesome. 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 Try that one. Tell me what that slope's going to be. Again, using your choice, Joseph. There you go, buddy. Joseph, I need to try a question here. Let's go. Yeah.
Oh, he's like 2 different charts.
What is the slope of my next equation here? Why do you have an airplane?
I'm gonna split this up now. Oh.